When federal agencies purchase software, they command budgets in the billions. That immense procurement power allows them to dictate exactly how private companies design their digital systems. Simultaneously, at the local level, individual jurisdictions are moving aggressively. Cities and states are deploying highly specific, localized laws designed to protect civil rights from algorithmic bias. As we can see in this abstract visualization, these two regulatory forces are colliding. On one side, a massive, monolithic structure of federal standards. On the other, a fractured, colorful terrain of state laws. Public administrators are caught right in the middle, forced to balance the necessity of adopting rapid technological advancements against the severe threat of stepping on these conflicting legal landmines. Welcome to Wandt Courseware, an AI-narrated technology video series. This series unpacks the latest lectures and thoughts from Professor Adam Scott Wandt at the John Jay College of Criminal Justice. To understand this complex regulatory environment, we will examine it through three pillars. First, we will decode the broad federal mandates, specifically Executive Orders 14110 and 14179. Second, we will look at how agencies actually implement these rules operationally using the NIST Risk Management Framework. And third, we will navigate the emerging, highly fractured patchwork of state-level legislative mandates. A public agency cannot afford to ignore any of these pieces. Failing to master all three guarantees operational failure, making a unified compliance model the only viable strategy for survival. This view of the White House North Portico reminds us where the overarching authority for current U.S. AI policy originates, the executive branch. Executive Order 14110, issued in late 2023, establishes strict baseline rules prioritizing AI safety, security, and equity across all federal operations. Following that, Executive Order 14179 operationalizes those goals, defining the strict implementation directives and internal agency oversight structures needed to ensure compliance. A major target of these orders is what policy calls dual-use foundation models. These are highly capable algorithms trained on broad data that can be adapted for a wide variety of tasks. Because they are so flexible, they offer massive utility, but they also pose severe, unpredictable administrative risks if deployed improperly. This diagram illustrates how the government manages risk. The federal mandates umbrella funnels through procurement power into commercial software, enforcing rigorous pre-deployment testing. To enforce this, departments must designate chief AI officers. They must maintain transparent AI inventory lists detailing what algorithms are running. These verification standards act as a rigorous filter, allowing only highly vetted software into the federal ecosystem. The federal strategy here is deliberate. The government is not waiting for Congress to pass unified laws outlawing poorly designed AI. Instead, they are reshaping commercial development standards by leveraging the massive gravity of government buying power. But executive orders are abstract. To translate that high-level policy into daily agency operations, public administrators rely on the NIST AI 101 Risk Management Framework. Merely mapping and measuring risks when a system is first deployed is no longer sufficient. Modern automated systems learn and adapt, which means the oversight must be equally dynamic. This graphic shows the core of that dynamic oversight, a central AI engine surrounded by active dials, gauges, and continuous looping arrows. This represents the absolute necessity to actively manage and govern systems over time. Before an algorithm is even allowed to run, administrators must establish strict risk tolerance thresholds, defining exactly how much error or bias the agency is willing to accept. This is crucial because of algorithmic drift, a phenomenon where a model's performance degrades over time because the real-world data it processes begins to differ from the data it was originally trained on. Watch how the data line representing performance is slowly deviating away from the established baseline. That deviation is drift, and it happens naturally as real-world conditions change. Detecting this drift must immediately trigger automated escalation pathways, halting the system or alerting human overseers to address the failure before it impacts the public. Achieving this level of governance requires an inclusive organizational culture. Agencies must mandate third-party reviews and maintain highly transparent documentation of their technical decisions. Integrating NIST standards directly into procurement workflows ensures mathematical models remain under active democratic oversight, preventing an initially compliant algorithm from quietly failing in the background. This map of the United States illustrates the next layer of complexity. We are moving from a unified, top-down federal approach to a rapidly evolving, bottom-up regulatory patchwork across individual states. Notice the distinct filter icons appearing over Colorado, Illinois, and New York City. Each of these local municipalities utilizes distinct regulatory mechanisms to protect their specific populations. Looking at this view of the Manhattan skyline, we see a dense, high-stakes municipal market that often dictates how corporations structure their compliance programs. Here, New York City implemented Local Law 144. It specifically mandates independent, annual bias audits for any automated software used in hiring decisions. To ensure transparency, Local Law 144 requires companies to publicly disclose the results of those audits. Moving to the Midwest, Illinois focuses on a different stage of the employment pipeline with its Artificial Intelligence Video Interview Act. This law forces employers to obtain explicit consumer consent before using algorithmic systems to screen applicants. Furthermore, it guarantees strict data deletion rights, allowing applicants to legally demand that their video data be destroyed. Out west, Colorado established a landmark AI consumer protection framework through Senate Bills 24-205 and 26-189. Colorado imposes a broad duty of care on developers and deployers of high-risk AI systems, legally requiring them to actively prevent algorithmic discrimination. Because there is no unified federal statute, this complex state-level patchwork is driving the industry. Developers must adopt these localized, stringent protections as their baseline standard nationwide to avoid liability. This pipeline diagram combines all the pieces we have discussed: the federal procurement umbrella, the continuous NIST governance loops, and the state patchwork filters. This is what a legally and operationally sound AI deployment looks like. It must satisfy multiple masters simultaneously. First, the system must pass through the broad, top-down federal procurement standards, set by Executive Orders 14110 and 14179. Once acquired, the system is maintained internally by active NIST governance loops, continuously monitored to prevent algorithmic drift. Finally, the system's actual output must successfully clear the specific state-level civil rights and privacy filters before it impacts a single citizen. For public administrators, success requires leveraging NIST's practical controls. It is the only reliable way to align internal agency operations with both top-down federal security mandates and localized civil rights protections. If you found this breakdown valuable, please like, follow, and subscribe for more deep dives into emerging technology, digital investigations, and the ideas shaping our future. Until next time, stay curious.